Hello everyone, so today we will learn together about risk and liability in engineering. So the first topic is about the introduction. The second topic is about the engineer's approach to risk. Next is the public's approach to risk. Fourth is the government regulators' approach to risk. And then we will also learn about communicating risk and public policy. Difficulties in determining the causes and likelihood of harm, the critical attitude, and also about the engineer's liability for risk, and then also about becoming a responsible engineer regarding risk, and then we will summarize for you what we learned. For introduction, the first point is we should know that engineering necessarily involves risk, and innovation usually increase the risk. Second one is safety is inversely proportional to risk. The higher we accept the risk, the lower will be the safety of the project. All engineering codes give a prominent place to safety, and it includes the engineers must hold the paramount safety, health, and welfare of the public. For the second topic, we will learn about three subtopics. The first subtopic is risk as the product of the probability and magnitude of harm. Second one is utilitarianism and acceptable risk. Last one is expanding the engineering account of risk, the capabilities approach to identifying harm and benefit. The first subtopic is we will learn about first what is risk. Risk is a compound measure of the probability and magnitude of adverse effect. The second one is risk is something that can be objectively measured and the product of the likelihood and magnitude of harm. Harm is an invention or limitation of a person's freedom or well-being. Harm in terms of things can be relatively easily quantified. Second subtopic, utilitarianism, the probability and magnitude of harm, and contains no implicit evaluations of whether a risk is morally acceptable. Second one is the product of the probability and the magnitude of harms is equally or exceeded by the product of the probability and magnitude of the benefit, determining the course of action that maximizes well-being. Okay, the next is adaptation of cost-benefit analysis. It may not be possible to anticipate all of the effects associated with each option. It's not always easy to translate all of the risk benefit into monetary terms. Cost-benefit analysis in its usual applications make no allowance for the distributions of costs and benefits. The cost-benefit analysis gives no place for informed consent to the risk imposed by technology. And then the third subtopic is limitations of identifying harm in engineering. First is often only the immediately apparent or focal consequences of a hazard are included. Both natural and engineering hazard might create opportunity. There remains a need for an accurate, uniform, and consistent metric to quantify the consequences from hazard. Current techniques do not demonstrate the connection between specific harm and losers. Capabilities approach. First is capabilities can be little lower temporarily as long no permanent damage is caused and people do not fall below an absolute minimum, capture the adverse effect and opportunities of hazard beyond the consequences traditionally considered. Focus attention on what should be primary concern in assessing the societal impact of hazard, a principal foundation for judging an acceptability and tolerability of risk. Risk, risky situations and acceptable risk. First is unacceptable risk is one which risk is freely assumed by free and informed consent or properly compensate. Free and informed consent. To give free and informed consent to the risks imposed by technology, three things are necessary. First is a person must not be coerced. A person must have relatively relative information. A person must be rational and competent enough to evaluate the information. Equity or justice. First, layperson approach follows more closely the ethics of respect or person than utilitarianism. Next topic is talk about risk management of toxic. According to Williams, first regulators could decide to regulate only when there is a probable connection between a substance and some undesirable effect, such a risk of cancer. The public cannot accept the risk because of the difficulties in establishing the acceptable levels of exposure to toxic substance where there is no danger. By the technologies, regulators could eliminate any possible for danger, but the result will expenditure of large sum of money and might also possibly pose risk to human. Engineers have obligation to minimize risk. The public comes to issue the risk from a very different approach, even though they are wrong because come from no expert source. The government regulation have a responsibility to protect the public from undue technologies risk. It sometimes will be biased to ignore risk by getting more money. Social society regarding risk must take into consideration. Limitations in detecting failure mode. Severe limitation in problems analysis. Analyzing includes it is not possible to anticipate all of the mechanical, physical, electrical, and chemical problems that might lead to failure. It is not possible to anticipate all of the types of human error that could lead to failure. The probabilities assigned to the failure modes are often highly conjectural and not based on solid experimental testing. We can never be sure we have all of the possible initiating events included on the event tree of place and right order. Next is limitation due to tight coupling and complex interactions. First is tight coupling. Tight coupling is two processes have connected each other where each process affects each others. The second one is complex interactions. Complex interaction is the two parts of system interact in unanticipated way which cause inability to predict consequences. Next is normalizing deviance and self-deception. First is increase the allowable deviations from proper standard of safety and acceptable risk. Two issues: the standards of tort law and protecting engineers from liability. The standards of tort law. A tort is an act of or omission that gives rise to injury or harm to another and amounts to a civil wrong for which courts impose liability. Litigations that seek redress from harm most commonly appeals to the law of torts, which deal with injuries to one person caused by another, usually as a result of fault or negligence of the injured party. Second is protecting engineers from liability. Engineers in real practice may encounter especially difficult considerations regarding liability and risk, and in some cases they may need additional protections from liability. The steps to become ethically responsible with regard to risk: be aware of the fact that risks are often hard to estimate and can be increased in ways that are subtle and treacherous. Be aware that there are different approaches to determinations of acceptable risk, and to assume the responsibility as the expert in technology to communicate issues regarding risk to the public with the full awareness that both public and government regulators have somewhat different agenda with regard risk. And putting in a summary, the concept of factors of safety is vital in engineering. The second one is all engineering codes give a prominent place to safety. And third one, for engineers, risk is factor to harm, and for acceptable risk is product of the probability and magnitude of harm is equal or exceed by the product of the probability and magnitude of the benefit. The method to analyze the cause of risk include fault trees and event